This is section 2.2. We're going to start talking about subsets. A subset uses this notation. Set A is a subset of set B if every element in set A is also an element in set B. So in other words, if I have set A, which is 1, 2, 3, and I have set B, which is 1, 2, 3, 4, we would say that A is a subset of B. Since 1, 2, 3 is also in this B subset, 1, 2, 3, and 4, we say that A is a subset of B. So every element in this one has to also be an element in the other one. If we put a line through it, then we say it is not a subset. And I'm not sure why they have that funky symbol there, but the symbols actually looks like that. The notation, this one, means that A is not a subset of B. A is not a subset of B if there is at least one element in set A that is not an element in set B. Be careful with this one. Every element is a subset of itself. So if I had the set 1, 2, it would be a subset of the set 1, 2. This is an example. So we have the set of all x such that x is a tattooed American and 25 is less than or equal to x's age is less than or equal to 29. And the second set, set of all x such that x is a tattooed American. So what this is saying is that the people who have tattoos and are between this age range right here are also within this set of tattooed Americans. So the people who have tattoos, they're Americans, and they're between the ages of 25 to 29, are part of the set of tattooed Americans. So we have set A, which is 1, 2, 3, and set B, which is 1, 2. The question is A a subset of B? That's the question. Well, is every element from A also in B? 1 is in B, 2 is in B, but 3 is not. So A is not a subset of B. Next question, is B a subset of A? Is B a subset of A? Well, is every element in B also in A? So 1 is also in A, 2 is also in A, so therefore B is a subset of A. So this, yes. I'm going to talk about proper subsets, and for some reason this gives students trouble. But I like to relate proper subsets to inequalities. So before I talk about proper subsets, let's talk about inequalities. So let's suppose I tell you that 7 is less than or equal to 7. Is this true? Yes. For 7 to be less than or equal to 7, it's not less than, it doesn't satisfy this part, but it does satisfy that part. Okay, so 7 is less than or equal to 7. Okay, so relating that to sets, we have the set 1, 2. It is a subset of the set 1, 2. But this isn't the only type of inequality we have. Let's look at 7 is less than 7. Is this true? No, that's not true. In the same way, we can talk about subsets. If we have the set 1, 2, And we use this symbol right here. 1, 2. Notice this was no because it doesn't have the equal to symbol underneath. In the same way, since there's no line underneath this right here, then this would be false. Now, we call this symbol a proper subset. No need to worry about the language, but this is called a proper subset, and this is just called a subset. So, subset, proper subset. But you can think of it as being similar to inequalities. As if it has a line underneath it, then it's allowed to be equal. No line, they are not allowed to be equal. So, set A is a proper subset of set B. We use this symbol right here. If set A is a subset of B and the sets A and B are not equal, the two sets cannot be equal to be a proper subset. So, in this example, we're trying to figure out whether it's a subset, a proper subset, or both. So we have set A, which is the set of all x such that x is a person and x lives in San Francisco. The set B, set of all x such that x is a person and x lives in California. So, does every person that lives in San Francisco also live in California? Yes. So we say A is a subset of B. The other question is it a proper subset? Is A equal to B? Is the people who live in San Francisco the only people that live in California? No. So we can say that A is a proper subset of B. Okay, so this is allowed because they're not equal. Example B, we have the set 2, 4, 6, 8, and we have 2, 8, 4, 6. So the question is every element in A also in B? Yes, so A is a subset of B. The next question, are the two sets equal to each other? Yes. Every element that's in one is also in the other. The two sets are equal. Since they are equal, we are not allowed to use that symbol, which is the proper subset symbol. So A is not a proper subset of B because the two sets are equal. The empty set. The empty set is always a subset of any set, regardless of the set you have. Now, as far as proper subset, if I were to say this would not be true. The empty set is not a proper subset of itself. Okay, remember, proper subset, they can't be equal. But as long as set B is not the empty set, so, I don't know, 1, 2, 3. This is going to be true for every set that's over here on this side. The empty set is always a proper subset of every set as long as this set is not the empty set. The number of subsets. So I want you to take a look at the empty set. It has 0 elements. The cardinal number is 0. And the subsets, the only subset of the empty set is itself, and that is one subset. If we have a set and it includes the element A, and it doesn't matter what this A is, it could be 1, it could be China, whatever, has one element, the subsets, it's going to be itself, also the empty set, has two subsets. Now we have a set with two elements. We're going to have itself, each one individual, and the empty set. That's 4 subsets. 3, we've got the whole thing, we've got the 2's, we've got each one individually, and we've got the empty set. There are 8 subsets. And what we want to do is be able to use this number to figure out this number. So let's take a look here at the number of subsets. We started out with 1, then we went to 2, then we went to 4, then we went to 8. Well, if you notice, each time we went down, we doubled, or we multiplied by 2. So this was 2 to the first power, but if I multiply by another 2, that's 2 to the second power. And if I multiply by another 2, I get 2 to the third power. And that also works for the first one, because 2 to the 0 power is 1. So if you look, this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. And it turns out that the power is the number of elements. So if I tell you you have a set that has 20 elements, the number of subsets would be 2 to the 20. If it has 300 elements, subsets 2 to the 300. So the formula for subsets, number of subsets, is 2 to the n. Now, if we want proper subsets, remember proper subsets, you have to get rid of the equal. Okay, so what did we do? We took 1 away from each of these subsets. So to get the proper subsets, we would find the number of subsets and then subtract off 1. The number of subsets is given by the formula 2 to the n. The number of proper subsets is given by the formula 2 to the n subtract 1. Find the number of subsets and the number of proper subsets. 1, 2, 3, 4, 5 elements. So we have 2 to the 5th. Proper subsets, we take away 1. So we have 2 to the 7th. Which is 128. And to get the proper subsets, we take away 1, or 127. The homework, 4 through 48, every 4.